Welcome to Study Loop.
So in this question, we have problem number 23.28, chapter number 23, electric potential. We are given that there is a solid conducting sphere having radius zero point 0.4 meter and there is some charge on this sphere, and at r distance we at r equals to 1.2 meter, the potential is 24 volt. And we have this formula here, and we will find out the value of the V center using these two formulas here and using this information. So first let us understand why this formula R for this configuration. Since this is a conducting sphere, so whatever the charge is on the sphere goes on the surface. So charge moves towards the surface and remains there. If the Q is positive, we will have configuration as follows. So this plus charge will go onto the surface. If it has negative charge, so the surface will have the negative charge. So the charge inside this conducting sphere is 0. So there is no charge anymore. And similarly for negative charge, there is no charge within the sphere. The charge moves on the surface. Charge moves on the surface. So having solid configuration of the conducting sphere is equivalent to spherical conducting shell. Shell means that it has just this sphere surface and there is no material inside. And due to this kind of configuration, we have potential equals to V inside. V inside means that the potential at any point between r equals to 0 and r equals to r, we have 1 by 4 pi epsilon naught q over r, which is equals to V surface. So the potential is constant between these 2 points. So this and this r equals to 0 and r equals to r. And V outside, which means that any point outside this sphere, means that r greater than r, we have 1 by 4 pi epsilon naught q over r. So we will use this formula and use this information to find out the V center. So we have V surface equals to V inside equals to V center, right? And this is equals to 1 by 4 pi epsilon naught q over r, and V 1.20 meter, or means that r equals to 1.2 meter, is equal to this formula 1 by 4 pi epsilon naught q over 1.2 meter, which is equals to 24 volt. You can use this equation to find out the q, but we can solve this V center or the potential at the center by using the ratio method. So we will use the ratio method here. We divide V surface over V1.2. V surface is 1 by 4 pi epsilon naught q over r, 1 by 4 pi epsilon naught q over r. So this cancels down, this cancels down, so this becomes r over r. We know the value of the r here and r here, so this is 1.2 over zero point 0.4. So this becomes 3. So V surface equals to 3 times V12. And what is the value of the V12? We have this information here, this information. So V12 is 24.0 volt. So this gives us 72.0 volt. So this is the potential at surface. We could find the Q here using this equation because we know everything here except Q. But we don't need to find Q because we just use this ratio method to find out the value of the V surface. And we know that V surface equals to V inside and which is equals to V center. So this is equal to the same answer. So V center is equal to 72.0 volt. So that's your answer. So saying that the sphere has some charge, has radius equals to zero point 0.4 meter. So the potential at this point is also equal to this point. So this is 72 volt. This has also 70.2 volt, and this point has also equal to 72.0 volt. So that's your answer. Thank you.